This is another sequential animation, so I won't be able to show you this again. Leads on from that the brief introduction last slide. The method of constructing each of these next models can you all see that? Good. Is to just simply take away, in each of those sedimentary basins, take away those sediments and put them back onto the exposed lands. Take away the volcanic rocks and granite rocks and put them back to where they came from. And just gradually close off each of those sedimentary basins back in time. It's a very, very slow, very minute amount of movement per year. As I mentioned, the radial increase is only a maximum of say 100 microns per year, which only equates to maybe a millimetre per year. And this is inconsequential on an Earth scale. This animation represents 95% of Earth history, 4,400 million years time history. And these are dated by modern dating techniques, so it's well constrained. The age of these rocks are very well constrained. The most ancient rocks in the world are presently about 4,000 million years old, and the most ancient meteorites and asteroidal rocks are around about 4,500 million years old. The coastlines shown on these animations, I don't know if you can see them there, outlined in blue, represent those same continental seas and the most ancient supercontinent, distribution of supercontinents, just slowly changing with time as the crustal, the size of the Earth changes. And these represent, moving forward in time, this represents Rodinia, Gondwana, as you've probably heard of, and also Pangaea supercontinents, and all the other minor continents like Laurasia, Laurussia and Laurentia, for instance. We won't go into that. And also the seas, and also the ancient seas, the Tethys, Panthalassa and Iapetus seas. And you see, as I hoped you'd see, this is very, very easy to visualise in this format and hopefully understand. And unfortunately, from a plate tectonic point of view, where we have a static radius Earth, and that yellow circle, by the way, is the present Earth, the radius of the present Earth. On a plate tectonic concept, we're led to believe that these fragments of continents randomly assemble and collide and disassemble in a random motion throughout the world. So we have this wham bang crash bang scenario, and as I hope you can appreciate that if that were true, then you cannot assemble these fragments back in time as I've assembled it. It's a physical impossibility. So this is what the primitive Archean Earth looks like. The radius is around about the same size as the Moon, the present Moon, about 22% of the present Earth radius. And this one model represents the Archean to Mesoproterozoic, and that's about 4,600 million years ago to 1,600 million years ago. If you recall back on that graph, that interval of time, we're only dealing with microns. A change in radius is only micron scale. So this one globe represents, that time interval represents about 60 kilometres change in Earth radius. And an Archean model would not look any different to that model there. So what's shown here is an assemblage of the most ancient crustal fragments in each of the present-day continents. Australia is well endowed with these ancient fragments, the West Australian shear right up into the Kimberley, Central Australia. Each of these fragments are represented here, whereas Eastern Australia are essentially young sedimentary and volcanic rocks. So on this concept, the expanding Earth concept, this material has been removed. The sediments have been returned to the ancient continents, ancient continental crustal fragments. As I hope you can all appreciate, this is where they came from. They're eroded, mechanically eroded, and been washed down the rivers and deposited in these sedimentary basins. So all you're doing, moving back in time, you're just simply returning them back to where they came from. And similarly, the volcanic rocks, they come from the mantle, so you just simply return them to the mantle, and the granites and the water and so on. These are what's left. These crustal fragments are what's left, and as I was alluding to before, on a plate tectonic scenario, this would be an impossible situation where these same fragments are being wham, bang, crash, bang, colliding into each other and then breaking up and dispersing at random, willy-nilly, all over the world. And as I mentioned right from the start, plate tectonic people do not use this oceanic mapping, so they cannot get to this level of confidence in reconstructions. Also shown on there is an outline of the location of the present-day continents, which you won't be able to see, but just flashed past was Antarctica, Greenland, Hudson Bay, so that's America. Just trying to sneak down the side there. So America, and Australia is tucked in there. Antarctica, India, etc.